What's poppin', dogs? Mr. Allen here with some graphs of rational functions. And in this video, we are going to write the function that goes along with these graphs, as well as list some other features of these graphs. First thing I like to do here is start with my asymptotes. I have a vertical asymptote of x equals 2. So that's going to go in my denominator of this function. We'll call it f of x. So f of x equals, and I'm going to start a fraction here. I'm not sure how big it's going to need to be, but I'll just give myself some room. And let's see here. My vertical asymptote was x equals 2. Might as well jot that down here. Then in my denominator, it's going to be x minus 2. Nice. All right, we're starting. We got it. We got the start going, right? And then let's see, what else do we have here? Well, I also have a hole. This hole is at 1, 2, 3 for my x, 2 for my y, so 3 comma 2. Sometimes they'll write that ordered pair down like we did here if it's like a fraction, but if it's at a nice spot, then they won't actually write it. At least that's what I do when I make these tests, okay? So I have a hole when x equals 3, which would mean that x minus 3 would need to cancel out, right? It's a removable discontinuity. And if they asked you for the hole, you would write that down here, but our hole is at 3 comma 2. So I've got that removed, okay? Beautiful. But right now, my numerator is x to the first power. My denominator, if FOILed out, multiplied out, would be x squared. Since my denominator overpowers that numerator, the degree in the numerator is smaller than that of the denominator, my horizontal asymptote would be y equals 0. And I think we can clearly see it's y equals 1. So something needs to change. I could add a number outside of this, or perhaps I need to put something else in my numerator, which would balance the degrees to both be x squared over x squared. And an easy way to do that is with my x-intercept. My x-intercepts are found in the numerator here because it's what would make my function 0. I don't want to make my denominator 0. That's undefined. But if my numerator is 0, 0 divided by something is 0, thus it's a y-intercept. Or sorry, yes, thus it's an x-intercept. So what do I need here for my x? Well, if x is 1, it equals 0, so my factor will be x minus 1. All right. Cool. So let's see how things are checking out here. My x-intercept we just said was 1 comma 0. I don't know my y-intercept. It's not listed there, but perhaps I can get it from my function. But let's double check everything first, okay? Once I get all my factors in place, I like to make sure that it does actually fit everything as I was on the move here. So my removable discontinuity would be occurring at x equals 3, because this would cancel out, right? Which would leave me with this function, f of x equals x minus 1 over x minus 2. I'm going to do a little side math up here. If we had x minus 1 over x minus 2, and if I plugged in 3 for x, would I get 2 out, right? That's what we want to make sure that we get the right, ordered pair here for my hole. So 3 minus 1 over 3 minus 2, that's going to be 2 in the numerator over 1. Yes, we do get 2. So that checks out, right? Boom, we're good here, right? Check mark. That's a weird looking check. I mean, it's okay. All right, so the hole works out, right? So this function's good for that. My vertical asymptote is x equals 2. Perfect. My numerator's degree is x squared when FOILed out. Denominator is x squared when FOILed out. Therefore, it's my coefficients out front here that are going to dictate that horizontal asymptote, which would be 1 over 1, y equals 1. So everything's pretty good here. My x-intercept, plug 1 in here, I get 0 for my output. Good stuff. All right. Now, the last thing that we want to check out is what's my y-intercept here? I guess not last thing, but we got those two as well. Y-intercept, what would that be? Well, the y-intercept happens when x is 0. So these are going to cancel out. It's a removable discontinuity, which leaves me with just this part right here, right? When it's in its simplified form. This is my answer that matches this because we got to have the stuff that can cancel. But if I plugged in 0 here, I'd be left with negative 1 over negative 2, which is positive 1/2. And that actually does, jive with the graph here, right? This right here looks like it could be at positive 1/2. So I think that's all wonderful, fine and dandy, if you will. All right, cool, man. That's awesome. Let's get some end behavior and some vertical asymptote behavior. Hopefully I can fit it there. It is a little bit tight. All right. So end behavior is as we go to the left and as we go to the right. So as I go to negative infinity, what's my blue graph approaching? It's approaching that asymptote there, which is y equals 1. So as x approaches negative infinity, f of x approaches positive 1. Boom, we fit it. And then as x approaches positive infinity, so as I go to the right here, What's f of x going to approach? Well, it's coming down, but it's still approaching positive 1. So f of x approaches 1. I like it. A little close proximity there, but hopefully we can read that. Okay. So as it approaches negative infinity and as it goes to positive infinity, or in words, as it goes to the left and to the right, it approaches 1. Now we got our vertical asymptote behavior. Some people ask for this, some people don't. If your teacher doesn't, whatever. But if it does, if they do, I got you, right? So as we approach this vertical asymptote, as I approach the value of 2, what's happening? Well, it's different on each side of the asymptote, right? So we need to have some notation here of telling you what side I'm approaching it from. So if I come from the left-hand side, from the negative side here, it's going to go down to negative infinity. So here's how we write this. As x approaches positive 2 from the left, we put a little like negative up in the exponent spot kind of thing. What are we approaching? F of x is approaching negative infinity. Kind of ran into the other problem there. Oops. All right. And then as x approaches 2 from the right, so from this side here, from the positive side, we're going up to positive infinity. So we would have, why did I put all these arrows? Sorry about that. That's a comma there. Comma, f of x approaches positive infinity. Cool. Beautiful. No wonder why I ran out of room there. I used an extra arrow. Psh, my goodness. All right, so those little exponent kind of things there, the negative and the positive, that's telling me from the left, from the right. Okay? I know the math notation is sometimes overwhelming, so I will try to repeat myself quite a bit on those different types of notations to hopefully help you out. Hope you remember it. All right, next one over here. Let's see. Same kind of deal, but we have a negative 2 for our horizontal asymptote. That's different than this one. Negative 1 for my vertical. Let's just write those down. So x equals negative 1, y equals negative 2. Okay. Let's see here. We got a hole at 2 comma negative 4/3. Interesting. We'll see how that all works out. A lot of times it just works out in the function. Sometimes with the more difficult ones, you may have to play around with some numbers. But Algebra 2 land, we're probably keeping it pretty basic here. It should work itself out. We'll just double check it at the end. So my function here, we'll call this one g of x. Give myself a nice little fraction there. I'm going to run into the vertical asymptote behavior. We'll deal with that later. All right, so let's see here. Vertical asymptote, that's got to be in the denominator, right? So we'll have an x plus 1 in my denominator. Cool. Because that will give me x cannot equal negative 1 as a domain restriction. Negative 1 would be where my vertical asymptote would be. We do have a hole at positive 2, so we'll do x minus 2, both numerator and denominator here. Because we want it to cancel out, right? That's a removable discontinuity. And then another interesting, so we have an x-intercept at 0, 0. So not only is that my x-intercept, it's also my y-intercept, right? It's crossing the x and the y-intercept at the same spot. So how does that look in my function? Well, if I plug in 0 for x, I should get 0 out. So really, I just need an x here, because if I plug in 0, it's going to be 0 times negative 2 times 1 times negative 2, which is 0. Okay? So it's just going to be an x. Anytime I see it go through the origin, I'm going to see an x in my equation, like solo like that. Okay? Now, the last thing we got to think about here is that I have x squared in the numerator, x squared in the denominator. If I multiplied it out, x times x is x squared, x times x, x squared. So my degrees in the numerator and denominator are the same thing. Thus, none of them are going to overpower each other, pushing us to 0 or an oblique asymptote, which you probably don't know about yet. So right now, my horizontal asymptote is 1, not negative 2. So what do? Well, I can shift this entire thing down 3 from positive 1 down to negative 2, but that's going to change a lot of other stuff here. So I don't know if I want to do that. What if I multiplied by negative 2 here? Made it just a negative 2x. Would that do the trick? Well, let's see here. Now I have x squared and x squared. So I look at my coefficients. It's negative 2 over 1, which is negative 2. That's good. Will the whole work out? Will the x and y intercept work out? And this other random point that we have over here, will that work out? Let's find out, okay? So if we plug in 2, right? So I'm going to write my simplified form here so we don't have to do as much math. So if I have, when we cancel out the x minus 2's, I'm left with this, right? That's the simplified form. Like if I was graphing this is not our answer. This is the answer. We want the full thing. But if I plugged in 2, would I get negative 4/3? 2 plugged in here would give me negative 4 over 2 plus 1 is, look at that. Okay, so I would get negative 4/3. That's a check. This guy's good. If I plugged in 0, would I get 0? Yes. So we're good here. We're good here. Okay? Now let's check this one. If I plugged in negative 2 for x, would I get negative 4? So if I plug in negative 2, will I get negative 4? When I do that, negative 2 going in here would give me negative 2 times negative 2 is positive 4. So I'd get 4 over, and then we'd have negative 2 plus 1 is negative 1. That's negative 4. All right. So this all works out. Everything is good. We got all points, all asymptotes. Everything's ready to rock in this one. We have our function. So if they just ask for the function, you're good to go. But if they ask for all the other stuff, we got a little more to do here. We got end behavior now. All right. So let's do the end behavior, and then we'll do the vertical asymptote end behavior maybe up in this little spot right here. So end behavior as x approaches negative infinity. I like to go to negative infinity first, positive infinity second. Some people start with the positive. Just make sure you're reading carefully, because a lot of times we'll set you up with the start. Let's see here. G of x. What's g of x going to approach? Well, as I go to the left, my purple graph is coming up to that horizontal asymptote, which is negative 2. So we got approaches, negative 2. Let me just erase that real quick. That looks just absolutely horrendous as I bump the microphone with this rag there. That probably sounded pretty dope. Let's try that again. Negative 2. Okay. And then as x approaches positive infinity, g of x is approaching also negative 2. I almost did an infinity again. All right. So you'll notice that the end behavior with rational functions, when you're not dealing with an oblique asymptote, which is slanted, they'll approach the same thing left and right. That is common. It's not some like, wow, that seems to happen a lot. No, it's always going to happen that way. If we have a horizontal asymptote, it is approaching that. So your horizontal asymptote value should always match your end behavior value if you have a horizontal asymptote. Last thing, vertical asymptote behavior. So VA behavior. Let's see here. We've got ourselves, let's see, right here. Boom. X equals negative 1. So as x approaches negative 1 from the left, so a little negative up there, as we come from this side, it's going down. G of x approaches negative infinity. And as x approaches negative 1 from the right, what's g of x doing? Well, as we come from the right-hand side here, whoop, we're shooting up to positive infinity. There we go. Cool, man. I love that. It's fantastic. All right. It's a lot of colors there. It's popping right there. So there we go, guys. They might ask you for all this information. They may just ask you for the function. But the general process for these is put my vertical asymptote, the factor that causes that, in the denominator first. If you have any removable discontinuities, throw those guys in, numerator and denominator. X-intercepts will be placed in my numerator. And then if I have to do any kind of finagling, I might add a little multiplier in there in the numerator to make things check out. Just take some practice there. They are kind of challenging, so if you're struggling with it, it's okay. Practice makes perfect, dogs. All right, that's about it. Have a great day.